With permutations, order matters. So when you do words, order matters. The moment you say you're arranging someone in a specific order, order matters, right? So anything like a digit number, a code, a password, a license plate, arranging people for a picture, arranging books in a bookshelf. Anytime you do a word, because order matters in a word, right? Like pool and loop are different words. So order matters. If order matters, it's a permutation, okay? So most of the things we've done so far where we did license plates or passwords or digit codes or words, all were permutations, you just didn't really know about it, okay? So if the order matters, it's a permutation, all right? All the ones that we've dealt with so far also don't have any repeating words. So today we're going to do repetition and we're going to do ones where you have to hold stuff together. So find the number of permutations of the letters in the word kitchen if the letters K, C, N must be together. So the very first thing we have to do is I always write the word out. K-I-T-C-H-E-N. Now that looks ridiculous because I'm just rewriting out the word. However, I always write out the word because if there's double ups or tripling ups of letters, I start stacking them underneath each other. So this way, because none of them are stacked underneath, I know that I have no repeating letters. Okay? Kitchen has how many letters? 7. Now it says the letters K, C, N must be together, but not necessarily in that order. We're using all the letters in the word kitchen because it doesn't say 4-letter words or 3-letter words, etc. So we're going to do 7 blanks. 1, 2, 3, 4, 5, 6, 7. Okay? Now it says we need to have K, C, N together, not necessarily in that order. We agree? Okay. So what I do to do that is I hook them together at the very front. So I'm pretending to hook my K, C, N together. We agree? But it doesn't say it has to be in that order, correct? If it had to be in that order, I would have K in the first blank, C in the next blank, N in the last blank, and I'd have 1, 1, 1 as my options above. We agree? But it doesn't have to be in KCN order, right? It could be in CKN order. It could be NCK order, right? It could be any order. So it's going to be 3. I have 3 options. Then how many do I have for this blank? 2. Let's pretend I keep the K. So I'd have CN. Then how many would I have for this blank? 1. Because with words, you can't repeat unless there actually is a repeating letter, right? We agree? Now, how many options do I have left for the back blanks? How many letters do I have left? 4, then 3, then 2, then 1. Will you agree? Okay. So if this said, and we'd be multiplying them. If this said KCN together at the front, we'd be done. We agree? But it doesn't say KCN together at the front, does it? It says KCN together. So what we have to remember that we can do is we can move it. So I can take this whole KCN, it's now sitting at the front of the word, technically, right? At the front of those 4 letters. So that's one way I can have these exact same numbers. We agree? Okay. So I want to go to the center page. So I have right currently now 3, 2, 1, 4, 3, 2, 1. You don't have to write this. I'm just proving to you why this works. So we currently have this, which is one way. We agree? Then we could take this KCN and we could put it between these 2 letters here, could we not? So I would have 4, 3, 2, 1. Don't write this, just pay attention. And then 3, 2, 1 still here. Like I moved all 3 of those letters in between those 2. Makes totally different word, does it not? But they're still together, are they not? Then I could go 4, 3, these 2 letters. 3, 2, 1. 2, 1. We agree? Or I could go 4, 3, 2. 3, 2, 1. 1. Right? Or I could go these 4 letters that are not KCN and put it completely at the back. We agree? Those are all the different ways we could do it. Remember how I said, what are the ways that you could make the word that has a G in it, and we put a G in the first blank, and we put a G in the second blank, and we put a G in the third blank, G in the fourth blank, they were all actually 120, so we just multiplied it by 4 instead of listing all the cases, right? This is really 3 factorial, 4 factorial, is it not? This top? Because it's 3, 2, 1, 4, 3, 2, 1, right? It's just 3 factorial times 4 factorial, is it not? Yeah? And then this one is actually 3 factorial, 4 factorial as well, is it not? And then is this one not the same thing, and this one not the same thing, this one not the same thing? So what we could have done is we could have went 3 factorial, 4 factorial times 5. We agree? Because they end up being the exact same, don't they? Okay, so let's go back to here, and there's got to be a better way than listing them all out, right? So what you can do to figure out how many there are is it's always one more than this number here. Why? Because they could be here at the front, which is one way. I want to use green. They could be here, which is at the front, which is one way, correct? Or we could put them between these two, which is 2 ways. Or we could put them here, which is 3 ways, 4 ways, or at the very back, which is 5. So we always multiply it by one more than this number after you're holding them together, because that's what's going to happen. You're going to have 1, 2, 3, 4, 5. So we actually multiply it by 5 because we have 5 of them that are exactly the same as that one, right? Do we agree? So the way they'll write the answer to this is they'll go 3 factorial, 5 factorial. They could go 3 factorial, 4 factorial times 5. But why do you think they'd go 3 factorial, 5 factorial instead? Right, because you can go 3, 2, 1, which is 3 factorial, and then 4, 3, 2, 1 times 5 is actually 5, 4, 3, 2, 1, which is 5 factorial, right? So that's what they'll do. Does that make sense? All right. What's 3 factorial times 5 factorial? I think it's 720. Okay. Now the next one, number of permutations, arrangement where order matters of the word letters in the word kitchen if the vowels must not be together. So pay attention, this is where I lose people. So we're going to, if it says not be together, we're going to do this first. So we're going to do number of ways we can rearrange kitchen, no restrictions. Okay? So how many ways can we rearrange kitchen, no rules? Just rearranging the word kitchen. How many letters are in kitchen? 7. So we have 1, 2, 3, 4, 5, 6, 7. How many options do I have for the first blank? Then? So how many ways can I rearrange kitchen? So that's the absolute maximum ways that I could rearrange kitchen. That is the most new words that I could come up with. Distinguishable words. We agree with the word kitchen. That's it. 7 factorial ways. We agree? All right. So the key word here is not together. Vowels must not be together. So side note, totally different thing. There's 13 of you in this class. Okay? And I say to you, how many students are not in this school but are not in this class? What would be the quickest way to do that? Walk to each classroom and be like, how many students do you have in your class? And hope you don't miss classroom. Then you'd have to find out how many people are on spare, ask them, add them all up, and then you'd find out how many people are not in this classroom. That's obviously the quickest way. That obviously is the worst way. Okay? So what would be the quickest way that you could tell me how many students are not in this class? Subtract, you guys, the number of people who are in this class from the total number of students. We agree? So if I want the students who are not in the class, the fast way to do that is total number of students minus the ones that are in this class. Yes? So if I want the ways that you can have the vowels not together, what would be the easiest way to do that? Really the only way. Yes, so we take the total number of words possible that we can make out of kitchen, which we figured out already, 7 factorial, just like the total number of students in this school, correct? And then we're going to subtract off, so this is total, and then we're going to subtract off vowels together, right? And if we take the total number of words possible and we subtract off all the words where the vowels are together, what's left over? Vowels not together. If you don't do this, you'd have to do cases, and it would be awful, and you're probably going to miss a few thousand, or a few hundred, not thousand. Okay? All right. So vowels together. So we have 1, 2, 3, 4, 5, 6, 7. How many vowels are in kitchen? The I and the E, right? So we're going to hook them together at the beginning. That's what we do. Does it say vowels together at the beginning? No, it says vowels together. So how many options do we have for this first blank? 2, E or I, right? Then we keep one of them there. I'll pretend to keep the E. Then we have the I, right? So we have 1. Now how many letters have we used up? 2. How many do we have left? 5, then 4, then 2, then 1. And people will say, okay, so I just take 7 factorial and I subtract 2 times 5 factorial. What am I missing? That extra step that says, hey, these don't say together, vowels together at the front, it's vowels together. So they could be at the front, or they could be between the 5 and 4, between the 4 and 3, between the 2 and 1, you know what I mean? So they could be here, which is one way, or 2, or here, 3, or here, 4, or here, 5, or here, 6. It's always one more than the blank after you put them together, correct? So our answer is actually 7 factorial minus 6 factorial times 2. You could go 2 factorial, or you could just say 2. Why can I say just 2 or 2 factorial? 2 factorial is 2, because 2 times 1 is 2. So what answer do we get? 3,600? So when it says not together, what you need to do is total no restrictions of the word, right? Like the total number of students in this school, and we subtract off the ways they are together, or we subtract off like the students in this class to find out how many are not in this class. Does that make sense? That's the biggest thing you guys need to take away from this. Okay. I want you guys to try example 2 and example 3 on your own, please. So we look at the word oranges. Are there any doubling or tripling? Nope. So there are no further restrictions. We need to arrange it. So how many letters are in oranges? We have 7, then 6, then 5, then 4, then 3, then 2, then 1. Or 7 factorial, which is? The first letter must be an N. So we're going to have 1, then 6, 5, 4, 3, 2, 1. Or just 6 factorial, technically. Or 1 times 6 factorial, which is still 6 factorial, which is how much? 720? The vowels must be together in the order OAE. Makes a difference, right? 1, 2, 3, 4, 5, 6, 7. We're going to hook them together. They need to be in the order OAE. So my options are 1, 1, 1. Then I have 4 letters left. 3, 2, 1. Does it say together at the front? No, so we have to be able to move them. So that's one way. 2, 3, 4, 5. So we multiply by 5. So it's 5 factorial, which is 120. How many arrangements of the words brains are the vowels together? So we have 1, 2, 3, 4, 5, 6. No doubling or tripling letters, right? How many vowels are there? 2. So we have 2 options for the first and 1 for the last. We have 4, 3, 2, 1 left. How many ways can we move it? Times what? 5. It's always one more than this, right? This is 1, 2, 3, 4, 5. So it's going to be 5 factorial times 2, which is 240. The next one says, in how many ways can 3 girls and 4 boys be arranged in a row if no 2 people of the same gender can sit together? What are we going to have to start with in order for that to be possible? 7 kids, 3 girls, 4 boys. Boy. So we'll have to have a boy, 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 boy. So it's going to be 4 3, 2, 1. And then what are we going to have for these ones? Girl, 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 which is 3, 2, 1. What's the quickest way to write that one out? If you look at the green and the blue. The green represents 4 factorial. Blue represents? Which is? How much? What if I changed it to 4 girls, 4 boys? How many do we have now? 8. Quickly, show of hands. Who would start with a girl? Who would start with a boy? Seriously, pick one, choose one. Can't fence it. Who would go start with a girl? Who would start with a boy? Does it matter which one you start with? No, it doesn't. Does your picture look different? Yes. So on tests, people do this. They go girl, girl, or boy. It doesn't matter. Whichever one you prefer, they start with. Right? And then they have 4, 3, 2, 1. And they have 4, 3, 2, 1. And then they say 4 factorial, 4 factorial. And they give me that answer, and that answer for sure is going to be there. It's incorrect. Because I started with a girl, and the other person started with a boy. Now, if you stood in a row, and you were arranging people, right, in a picture, and you go boy, girl, boy, girl, boy, girl, boy, girl, or you go girl, boy, girl, boy, girl, boy, girl, boy, does the picture look different? Yes. So what do we actually have to do to get the correct answer? Multiply it by 2. Or you could just rewrite out the next scenario and add them, which is the same as multiplying by 2, because you get 4, 3, 2, 4, 4, 3, 3, 2, 2, 1, 1 again. Would you not? We can just multiply by 2. Because if you did it the other way, you had boy, girl, boy, girl, boy, girl, boy, oh, girl. You'd have 4, 4, 3, 3, 2, 2, 1, 1. You'd have the exact same answer, right? So you could add them, or you could multiply by 2 and you get the same thing. So what's your answer? What do we get? The next one has 6 actors and 8 actresses are available for a play with 4 male roles. It should say with 4 different male roles and 4 different female roles. It should say different, or else this does become quite a 3. Sorry, 4 males, 3 females. 6 actors, 8 actresses. Okay? This is a permutation and not a combination, because the order in which you get picked matters. It's 4. So I always was like, oh, if you're picked 4th and then 5th, the order matters. That's not how it works. It matters on the ones that you're picking. So I'm picking 4 male roles, 4 different male roles. We agree? So does it matter in which order you're picked for those male roles if they're all different? Yeah, if you're picked first, you're this certain role. If you're picked second, you're this certain role. If you're picked third, you're this certain role. If you're picked fourth, you're this certain role, right? So you could be the lead or you could be a background. It makes a big difference, right? A big difference. So the order in which you pick those 4 people, if whatever you're choosing has specific roles, order matters because you're getting different roles. It's like if you have student council and you're picking a president, secretary, and treasurer, right? The order in which you pick those people matters because they have 3 different jobs, correct? But if you were just picking 3 people to be on student council, like on a subcommittee from the council, and they all had the same job, then would the order you pick those 3 matter? No, because they're getting the exact same job. If you're picking a 3-person subcommittee from student council, right, and they all had the same job, the order in which you pick those 3 wouldn't matter because they all end up with the same job. If you're picked first or you pick third, maybe less stressful, because third would be like, oh, am I getting picked? But it makes no difference because you have the same job. So if you have specific jobs or specific roles, it's a permutation. Okay? So we're going to go like this. Only way we can guarantee getting actors, like the male roles, is picking them from actors. Okay, actors are the boy roles, actresses are the girl roles. Okay, so we're going to have 6 actors, and we're going to pick the P because it's a permutation, because order matters. If order matters, if there's specific roles, it's a P, not a C. It makes a big difference. Okay, so 6P, and how many are we choosing? 4. And then we do the actresses, 8 actresses, 3 female roles. So it's going to be 8P3. It's a permutation because order matters. In which I pick those 3 people, they get different jobs. Now I have to decide, do I multiply these or add them? Well, do I need the 4 males and 3 females? Is that what I'm picking, the 4 males and 3 females? Or am I picking the 4 males or 3 females? And if I say or, then the 4 male roles or the 3 female roles, I'm only picking one or the other, right? Do I want to pick one or the other? Do I want to pick both? So I multiply. Type that into your calculator, and you can type it in just like that. 6P3, 8P3. Oops. If you have this one that puts them down like this, you have to arrow up times. It was 4, wasn't it? 6P4? I have the wrong number. $120,960. Everyone get that? If you didn't get it, you may not have arrowed up to do your multiplication. It might have had a multiplication down here, which makes a big difference. Yep. You can only do it though, like you can only do the lines if you're choosing one of each and no repetitions. So if, say, that one person could get more than one role, you no longer can do FCP. You have to do FCP, I guess. You have to go 8, 8, 8. The P, this P here, only works if you're going down. So no repetition. So if we're using that same person 3 times, I couldn't go 8P3, right? I'd have to go 8 times 8 times 8. I'd actually have to do FCP if there's repetition. Yeah, you absolutely can. Because this is the exact same as, oops, 4 blanks, 6, 5, 4, 3, 8, 7, 6. Yeah? You get the exact same answer, which is 1, 2, 0, 9, I can't remember, 6, 0. Okay. I'm going to give you some homework. We do repetition and what's it called tomorrow? Start combinations tomorrow.